Okay, there's two vectors in the plane that are called standard unit vectors, and they're represented by the letters I, lowercase letter I and lowercase letter j. And again, in your book, it'll be a bold I and a bold j, but we can't do that. So I'm writing it with I and a little arrow on the top, j with a little arrow on the top. The I vector is 1, 0. In component form, 1, 0. So it's a vector of unit, it's length 1, right, in the direction of x, totally in the direction of x. It's not at any angle, it just starts at the origin 1 to the right. Right. The j vector is a 0, 1, which means it's unit 1, it's length of 1, and it starts at the origin, and it goes totally in the direction of y. These are used to give us another way to represent vectors, which you might not prefer. You may prefer actually the component form. But the fact is that the book about half the time, or a significant portion of the time, is actually going to use these when they're trying to write a vector and not the component form. So you at least need to know how they're similar. I mean, in this example here, it says, write a linear combination of unit vectors, right? So this is a different format. Instead of component form, it's a linear combination of the standard unit vectors I and j, right? They've given us an initial point and a terminal point, and we know how we would find the component form, right? We would subtract the terminal point minus the initial point and get -3, 8. That's component form. The linear combination of the standard unit vectors is -3i plus 8j. And if you want to see how that works, just substitute for I and j. Right? That would be -3 times 1, 0 plus 8 times 0, 1. Right? That's two scalar multiplications. Right? That would be -3, 0 plus 0, 8. And then it's a vector addition. And that equals -3, 8. So this is just a different way to write a vector as a linear combination of the standard unit vectors.